Hello and welcome to Nick's Maths, Term 3, Week 3, Lesson 12, Multiplication as an Algorithm. An algorithm is a set of rules or a method you use to solve a problem. In today's lesson, we'll be looking at single and double-digit multiplicative algorithms and exploring patterns and means to find reasonable outcomes or answers. Now, algorithm, the word, it derives from a famous Arabic mathematician called Al-Khwarizmi. He's credited with developing mathematical processes. His most famous is the development of algebra. Now, using a step-by-step process is an effective way to learn and manage equations that involve large numbers. So that's what we're going to try and do today. I'm going to take it very slowly and very methodically. Our learning intention today, we are learning how to write and complete a single or double-digit equation using an algorithm. And you'll know that you'll be able to do that if you can successfully represent multiplication problems as an algorithm. If you can understand the process of multiplication with single digits, if you can understand the process of multiplication with double digits, if you can understand the process of multiplication in an algorithm using both single and double digits and can successfully get the answer right, apply your understanding. Now, some difficulties. Students may be used to doing equations in different ways. Some do them horizontally, some do them vertically, some do them as a lattice. Lots of people do equations different ways, and we'll try it a couple of different ways today. Students might resort to trying to solve the algorithm as an addition problem. 5 times 15, I'll just write 15 5 times and add it together. It'll take too long. They may be unfamiliar with the mathematical language that I'm using. Algorithm, I told you where it came from, and I told you that it's a way of solving a problem. They might be missing the basic recall skills of their times tables. So you might not know what 5 1s are or 5 8s are. You might not have got that far yet. And that's okay. We can go through this slowly and together. So you need a pencil, a rubber, sheets of paper, and texters or coloured pencils. The language that you're using today, you might use algorithm, a set of rules or method that you use to solve a problem. You might use multiplication, the process or skill of multiplying. You might use division, splitting a quantity into smaller groups. You might use the word equation, which is a sum or means to solving a problem. So the instructions. We're going to go through the equations that I've set on my learning task, which is this sheet, in your mathematics book. Now, it's good that you use the grid on your paper, and I'm going to show you how we're going to do that. So, for example, the first sum that I've set on the sheet is 11 times 5, and we're going to do it this way. So there's 11 times 5. We take the multiplier, which is the number here, and we times, using our times tables, the number above. 1 times 5, 5 times 1, is 5. And then we go diagonally across and times the tens. 5 times 1 is 5. And we get our answer. So we go vertically, then we go diagonally, and that gives us the answer. But you say, what if it's 2 digits that are multiplying a 2-digit number? Well, let's try it with this one. I've done this one a little bit earlier, so we don't waste time. Now, this algorithm shows us it's 12 times 17. So we do the units first. 2 times 7 is 14. So we put the 4 there, and the 1 goes above the tens in the next column. 2 times 1 is 2. Plus 1 is 3. So that comes down here. Now, we've done the units, we're doing the tens now. And we multiply diagonally across and diagonally up. 1 times 7. Now, the first thing we do, which is very, very important, is this is not a 1. This is a 10. So we put the 10, the 0 part, down here before we even start the sum. Then we do 1 times 7 is 7. And 1 times 1 is 1. Then we add the product of the units multiplication and the tens multiplication. We add them together. 4 times 0 is 4. 3 times 7 is 10. Put the 1 there. This one comes up over here. 1 times 1 is 2. And our answer is 204. Now you might say, Nick, you've gone too quick. But I've shown it in a step-by-step process, and I'll do it again just to consolidate it with you. And we'll do it in class as well. So when you're doing a double-digit multiplication, you do the ones first. 2 times 7 is 14. The 4 goes down there. And the 1, the 10, goes up above the tens column. 2 times 1 is 2, plus that 1 is 3. Then we go and move across. This is not a 1, it's a 10, so the 0 goes down here. Then we have 1 times 7 is 7, 1 times 1 is 1, plus this 1, we add them all together now. 4 plus 0 is 4, 3 plus 7 is 10, 0 goes there, the 1 goes up here, 1 plus 1 is 2, 204. Now again, you might say, Nick, that is too hard, you went too quick. So let's try it a different way. And all I want you to do is to try, and we'll go through it in class. Let's do it the lattice way. Now with the lattice, you make a square. And you put the square, you put the multiplying number, which is 12, against the number that's going to be multiplied, which is 17. Okay? And you break it into a grid, and then you diagonally across. They do this in Russia, apparently. Then you do 1 times 7 is 7. So there's no tens, you put a 0, and you put 7 ones there. 2 times 7 is 14. So there's 1 10 and 4 ones. Then you go across and you do this one over here. 1 times 1 is 1. So there's no tens, put it there. And then 1 times 2 is 2. There's no tens there. Then you add them diagonally. So my first one in the ones unit is a 4. Now in the tens unit, we've got 7 plus 1 is 8, plus 2 is 10. So the 10 goes down there. And the 1 goes up here. Then 1 plus 0 plus 1 in the hundreds one equals 2. And that gives us our answer, 204. I'm going to go through the lattice technique in class as well. So you can either try the lattice technique or you can try the conventional algorithm, which looks like that. Okay, the single digit ones we should be able to do as conventional algorithm, and we can try and do the lattice ones with the 2-digit ones. Now there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 equations for you to do. Have a go, see how you go, and if you have difficulties, we can go through it in class. Then, once you've done those, ask yourself these questions. Do you understand what an algorithm is? It's basically a sum or an equation or a way of working out something. How did you work out the equations? Explain. Did you use the single-digit one, or did you use the double-digit one? Did you use lattices? Or do you have a way of your own that you could share with the whole class? What did you learn as a mathematician? What can you teach as a mathematician? How do you know your understanding is correct? Can you explain that? What are some of the difficulties that you faced doing this task? And our maths is getting harder, so there's lots more difficulties. Now, once you've completed, let's say, 10 or 15 of these equations, please send annotated photos uploaded to Compass, or if this is too difficult, write a response and upload a JPEG as a Word document, or send it to me on my email, or show me at a maths lesson. We'll be doing this on Thursday, so I'll be able to go through it together as the class. Thank you so much, stay safe, and keep on mathemating.